Hello, good evening everyone. Today's paper discussion for phase 1. Just confirm once, audio, video, everything is okay. Good evening, good evening. Audio, video, is it okay? Hello, hello. Okay. How the studies are going on? Studies are going on well? Okay. Clear, clear. Good, good. Okay, so we'll discuss questions here. Question number 2. Octet rule is not followed in. So in case of ammonia, nitrogen, you're knowing nitrogen atom is having 5 electrons in the valence shell, and hydrogen is going to form single bond. So 3 hydrogens are there, 3 single bonds. So 5 electrons are there in the valence shell of nitrogen atom and 3 bonds formed. So 5 plus 3, 8. So nitrogen is following octet rule. It is having 8 electrons in the valence shell of nitrogen atom in the ammonia molecule. While hydrogen is following duplet rule. Hydrogen is having 2 electrons. Okay, now why I am writing this, I will clarify. Next, CH3 minus given. In case of CH3 minus, it is carbon minus. So carbon atom means 4 electrons in the valence shell. Carbon minus means 5. And hydrogen, 3 hydrogen atoms are given there. So it is having this kind of arrangement. It is minus charge. So now 5 electrons in the valence shell of carbon minus and 3 bonds form. So carbon is having 8 electrons in the valence shell for the given carbon atom. And here hydrogen is following duplet rule. Okay. Question number, option number 3, carbon dioxide, C double bond O, double bond O. Carbon atom 4 electrons in the valence shell plus 4 bonds. So 8 electrons. Oxygen atom 6 electrons in the valence shell and 2 bonds. So oxygen is also following octet rule here. In case of NO, nitrogen atom, if it is nitrogen atom only, non-bonded obviously, so 5 electrons in the valence shell and 2 bonds formed, 5 plus 2, 7 electrons. And oxygen is following octet rule here. So this nitrogen is not able to follow octet rule. So based on this we can answer here option number 4. Now why I wrote hydrogens also? Let's say I modify this question and I ask octet rule, in which case octet rule is followed by all the atoms. Then answer cannot be NH3 and CH3 minus. Because in case of NH3, hydrogen is going for duplet rule. CH3 minus going in CH3, carbon going for octet rule and hydrogen going for duplet rule. But question is, listen question carefully. If I modify this question, in which case octet rule is followed by all the atoms. All the atoms means if they are emphasizing on this term, all the atoms, then I will consider central as well as the surrounding. Okay, so all the atoms are following octet rule. In this case, answer will be CO2. This is also one possible question. If they are saying octet rule followed by which of the following molecule, then we can go for 1, 2, 3. All the atoms, then CO2. If octet rule followed, they are asking. Okay, by all the atoms. Okay. So I wrote because of this concept, they can ask one more question here. Next. Okay, Neil Bartlett, that will be discussed by Pansar. Okay, question number 7. Which sodium salt will be heated with the soda lime to obtain propane? Heated with the soda lime. Recognize the reaction. Heated with soda lime means which reaction? Decarboxylation reaction. In decarboxylation, what is happening? You are knowing RCO minus Na plus heated with the soda lime. Soda lime means sodium hydroxide, calcium oxide mixture. Then what is formed there? RH is formed. And this will come out as Na2CO3. This will come out as Na2CO3. Is it clear or not? So now observe the options given here. This part will come out as Na2CO3. So this part will left. So ethane will form here. In this case, this part will come out as Na2CO3. This part will left. So this part means 3 carbon straight chain. Propane will form here. In this case, observe this third option. It is given here CH3 twice CH. Means CH3 CH CO minus Na plus. C double bond O, and this is CH3 here. CH3 twice, CHCONA. So now this part will come out as Na2CO3. This part will come out as Na2CO3, and one hydrogen bind here, so this becomes CH2. So after the reaction, what I'll get here? CH3, CH2, CH3. CH3, CH2, CH3 is also propane here. So in this case, answer can be 2 and 3. They can give propane. Next question. When given compound is reduced by the lithium aluminium hydride, so you're knowing lithium aluminium hydride will reduce carboxylic acid functional group into the alcoholic functional group and will not affect carbon-carbon double or triple bond. So this carbon-carbon double bond or triple bond, if it is present in some case, double bond is not affected and carboxylic acid functional group reduced into the alcohol. Okay, chalo, next question. Parachlorobenzene has higher melting point than ortho and meta isomers. Dichlorobenzene, I have three possibilities for the dichlorobenzene. 1,2-dichlorobenzene or ortho, 1,3-dichlorobenzene or meta, and 1,4-dichlorobenzene means para. If I talk about the melting point largely depends on packing, and you knowing in case of para, it is having good packing as compared to the ortho and meta. In case of ortho and meta, this boundary is not perfectly symmetrical here. This is some point of para, isomer, ortho and meta. So melting point is here more for the para, ortho meta almost equal. Okay, so they are saying here para dichlorobenzene has higher melting point than ortho and meta isomers. So true. The treatment of alkyl chloride with the aqueous KOH leads to the formation of alkene. You are knowing alkyl chloride is treated with the aqueous KOH. It is going for SN reaction and it is giving alcohol. If I treat this with alcoholic KOH and heating also required, then going for the E2 reaction and giving alkene. Now what they are saying here, the treatment of alkyl but with the aqueous KOH leads to the formation of alkenes. No, alkene is formed in the presence of alcoholic KOH, and in the presence of alcoholic KOH leads to the alcohol. No, they are writing opposite statement, means statement 2 is wrong. Okay, question number 12, strongest conjugate base. So knowing order of acidic strength for HX, HF, HCl, HBr, HI. This is the order of acidic strength. So what we are knowing, stronger is the acid, weaker conjugate base. So if I am writing the basic strength for the conjugate base of HF is F minus, for HCl conjugate base Cl minus, for HBr Br minus, and for HI I minus. What we are knowing, stronger acid, weaker conjugate base. Weaker acid, stronger conjugate base. So here basic strength of F minus is more than I minus. The strongest conjugate base answer is F minus based on the 4 options given here. Next question. Which of the following is amphoteric oxide? Amphoteric oxide. So one trick was given to you. From that trick you can easily find amphoteric oxides. Prabhas Allu Arjun Garu beat Sanjay as he was singing Jan Gan Man in Bad Sabdam. So from that you can find the amphoteric oxides. Okay. So based on this, in case of chromium, intermediate oxidation state is amphoteric oxide. Chromium oxide is basic oxide. Highest oxidation state of chromium manganese, they are acidic oxide. So manganese and chromium in highest oxidation state, their oxides are acidic oxides. Cr2O3 intermediate oxidation state is amphoteric. CRO is basic oxide. V2O5 is amphoteric, predominantly acidic. Directly memorize for V2O5, it is amphoteric, predominantly acidic. Question number 16. Peroxide, if it is not observed for the addition of HCl and HI to alkene. Perfectly right. You're knowing peroxide if it is observed with the HBr, not with HCl or HI. What the reason? In case of HCl, bond is strong, so homolytic bond fission is not observed. In case of HI, bond is weaker, but iodine radicals are combining to giving iodine molecule. So let's read the reason given there. It is due to the fact that HCl bond being strong than HBr bond not cleaved by the free radical. Perfectly right. Whereas HI bond is weaker and iodine free radical combine to form iodine molecule instead of adding to the double bond. So assertion is true. R2 and R is the correct explanation of A. Next question. Question number 17. Increasing order of rate of HCN addition to the compound A to D. What is given here? First compound is given formaldehyde. First compound is given formaldehyde. Second compound is given acetone, CH3 C double bond O CH3 acetone. Third compound is acetophenone, pH CO CH3. And fourth compound is benzophenone, pH C double bond O pH. Very easy question. Nucleophilic addition reaction. In first one is aldehyde and others are ketone. So aldehyde more reactive than the ketones. All these three are ketones. So aliphatic versus aromatic. Aliphatic more reactive than aromatic. Now these two are aromatic. So how to check? This side, both side aromatic ring present. In this case, only one side present. So this is more reactive than the last one. So this is a decreasing order of reactivity here. So here you can simply answer A is most reactive, then B, C, and then D is least reactive. I'm repeating again. Aldehyde more reactive than aldehydes are in general more reactive than ketones for the nucleophilic addition reaction. So aldehydes. So one is more than other three. Aliphatic aldehyde more reactive than the aromatic aldehydes. Likewise, aliphatic ketones. Aliphatic ketones are more reactive than aromatic ketones. So aliphatic ketones are more reactive than the aromatic ketones. So 2 is more than 3 and 4. Here aromatic group present both the sides. This is least reactive. Does it depends on steric hindrance? Yes, it depends on steric hindrance. H will provide least hindrance. H will provide least hindrance. That's why it is most reactive. Two factors are there: electronic factor and steric factor. Electronic factor and steric factor. Okay. Okay, got it? Chalo. Understood na? Chalo. Next question. They are saying, assuming no other changes, what is the effect on rate of the reaction if concentration of both alkyl halide and nucleophile are doubled? Very good question. What is given? CH3Br given, CH3Br given, methyl compound given, methyl halide given, and OH minus nucleophile given. This will go for which reaction? SN2 reaction. In case of SN2 reaction, rate law is rate is equal to rate constant into the concentration of alkyl halide to the power 1, concentration of nucleophile to the power 1. If it is SN1, then alkyl halide power 1, nucleophile power 0. If it is SN1, SN2, alkyl halide power 1, nucleophile power 1. Now what they are saying, कि both alkyl halide and nucleophile are doubled. So if I double this 2 power 1, 2. If I double this 2 power 1, 2. So 2 into 2, 4. Means rate become 4 times. Okay. 4 times is quadruple, obviously. Question number 22. Which of the following species will have largest and the smallest size amongst? Okay. Now read here. Options are given Mg, Mg2 plus Al, Al3 plus. Mg2 plus and Al3 plus, they are cations, and magnesium and aluminium, they are neutral. And they are neighboring elements also. So we can say they are neighboring elements. So we can simply answer the cations are smaller than the neutral. So magnesium 2 plus and aluminium 3 plus are smaller than magnesium and aluminium. Then how to check these two? So knowing when you're moving left to right in a period, radius is going to decrease. So as you're moving from magnesium and then aluminium, moving from magnesium to aluminium, Z effective increases and radius decreases. So means magnesium is more than aluminium. How to solve these two cases? They are isoelectronic. For isoelectronic, what we are knowing? More plus charge, less radius. More plus charge, isoelectronic. Isoelectronic. More positive charge, less radius. So based on that, I can say Mg2 plus is having bigger radius than aluminium 3 plus. So who is maximum here? Magnesium. And who is least here? Aluminium 3 plus. Good question, directly from NCERT. Next, chloro compound of vanadium has only, okay, this will be, okay, has only spin magnetic moment of 1.73 Bohr's magneton. This vanadium chloride has the formula, color of the aqueous solution. Now they are saying magnetic moment 1.73. So if magnetic moment is 1.73, means number of electron 1, number of electron 1. Electronic configuration of vanadium, atomic number of vanadium, scandium, titanium, vanadium, 21, 22, 23, means I can say that 3d3, 4s2. If it is vanadium 2 plus, 2 electrons of 4 is gone, it is going to be 3d3. Am I right or not? If it is vanadium 3 plus, vanadium 3 plus, 1 electron of 3d also gone, it becomes 3d2. If it is vanadium 4 plus, it is going to be 3d1. Is it clear now? And if it is vanadium plus 5, it is going to be 3d0. So they are saying magnetic moment 1.73 means unpaired electron count 1. So vanadium plus 4. Vanadium plus 4. Which option? Second option. Is it clear or not? And you memorize the color for the aqua complex of vanadium 2, vanadium 3 and vanadium 4 also. Memorize color of aqua complex of vanadium 2, vanadium 3 and vanadium 4 plus. Vanadium 5 plus D0, so colorless aqua complex. Question number 24. Which of the following is not a double salt but the complex salt? Directly, easy question, easy question. Number 4 is actually K4